Hey, this is my final project presentation for object-oriented programming. I'll first talk about static and non-static instant variables in Java. A variable provides us with name storage that our programs can manipulate. There are two types of data variables in a class. Non-static instance, it declares in a class, outside a method constructor or a block, is created with the word new. It's destroyed when the object is destroyed, and it's property of an object. Static, it's declared in a class, outside a method constructor or a block, created with the static keyword, and there's one copy of each class variable per class. It's property of class, not of an object. Static methods can't use non-static instant variables. A static method can't refer to any instant variables of a class. The static method doesn't know which instant variables values to use. The keyword static lets the method run without an instance of the class. It belongs to the class, so there's no need to create an instance of the class to access it. To create the static method in Java, you prefix the static word before the name of the method. A static method is called using the class name, method name, as opposed to an instant reference. A memory is allocated for these variables at the time of loading the class, only once in the program. Static variables can access with class reference, and this would be the syntax for that. A non-static method does not have the keyword static before the name of the method. A non-static method belongs to an object of the class, and you have to create an instance of the class to access it. Non-static methods can access any static method and any static variable without creating an instance of the class. Now here you can see my code. A non-static method is always accessed using the object of the class shown here. The calling of the non-static method and using the object of the class. And this would be the syntax for that. Now, lists can have different characteristics. As the game progresses, items can be added or removed from the list. Some lists contain objects of different data types, while other lists contain objects of the same type. Some lists are constant, where the values cannot change. Java provides three different types of objects. We have array, enum, and array list. Now there are guidelines to determine which is best to use. For an array, you can have a fixed length. It's dynamically change the items in the list, and it has the same data type. With enums, it has a fixed length, items are constant and can't change, and same data type. Array list, you can add and remove objects from the list, and objects in the list are different data types. Most programming languages support arrays. Arrays are fixed length lists that may contain either primitive values or objects created from the class. All the elements in an array, however, must have the same data type. They allow you to dynamically change or modify the items, and the elements in the list are referenced by their index position. The index is an integer value indicating the relative offset of the element from the start of the list. An array is a data structure that is used to store a fixed size collection of elements of the same type. In Java, arrays are objects of the array class. They can hold primitive data and objects, and before it can be used in a program, it needs to declare a reference to the array and specify the type of data to be stored in it. Now I'll show you part of the code I wrote for the map class. After declaring here, the array is created using the new operator. Okay, so we have the map constructor. It sets the rows and the column values, and then the locations object, and the parameters are the row count and the column count. Java ships with a class called an array list. The array list class allows you to create variable length lists of objects. You can dynamically add and remove objects from the list at runtime. The objects in the list may be of different data types. Primitive values cannot be directly put in an array list. They must be converted into an object before being placed in the list. The elements in the array list are also addressed by an index. Array lists are most flexible of the three different types of lists, but we don't use them all the time for a reason. It really depends on how the lists are used. Arrays and enums can be much more efficient to use from a performance perspective, but the length of the list is fixed. I can explain this better by taking a look at my animal list that I created. Array list variables are defined by first specifying the class name, ArrayList, and followed by the data type of the elements in the list enclosed within the greater or less than characters, followed by the name of the variable, ArrayList variable name. An array list is created using the new keyword followed by the name of the class, ArrayList, optionally followed by the data type enclosed within the greater than less than, followed by the parentheses. New array list. The different animals are then added here. We have the horse, cow, chicken, and pig, and their quantity. Java supports a special type of class called an enum. Enums allow you to create fixed-length constant lists. An initial value or object must be assigned to every position in the list when creating an enum. Unlike an array, the elements stored in the list can never change. They are constant. The elements in an enum are not referenced by an index. Instead, they are referenced by the name assigned to each element at creation, the name map of the specific element in the list. Here's an illustration of the actor enum class defined for the game. Each element is an actor object. The keyword assigned to each element corresponds to the name of the actor. When navigating a one-dimensional array, there are many times that you will need to navigate through the list of elements in an array. For example, you may need to display all the items in an array or add up the total of all the elements in the array. For this, we would use the for statement. This is the most basic format for navigating through the list of items. In this example, the for statement first initializes the counter variable I to 0 and repeats the block of code enclosed within the curly braces while the value of I is less than the max row array. The for repetition statement increments the counter variable after each repetition through the loop. The counter variable is used to indicate the number of times the loop is repeated. It also indicates the index position of the current element in the list. For example, the first time through the loop, the variable I has a value of 1, so max row I. Each time the block of the code is repeated, the variable I is incremented and will contain the value of the index of the next element in the list. This process continues until the variable I is equal to the length of the array. At this point, the loop exists. One of the advantages of using the basic for statement is that it allows you to navigate through only a portion of the array. This can be done by setting the initial value of the counter variable I to starting index in the array and by setting the ending condition to terminate the loop at the index position where you want to end navigating the array. We can initialize the counter variable I to start the index, and whatever is here at the ending index will mean that whatever is less than the number here will be the ending index. Something important to remember is that the first index of the array is always 0 and the last index of the array is always the length of the array minus 1. Compile errors occur when one of the rules of the language is violated, such as leaving off a semicolon or mistyping the name of a variable. These errors occur and are detected at compile time before your program starts to execute. Runtime errors occur. There is a logic or system error when the program is running. Your program will abruptly terminate with an exception and print an error that the end user most likely will not understand. However, we can write special code in the program called an exception handler to try and resolve the problem. To explain this, I will share some of the code from my byland method after I added the exceptions. First, I changed the return type to void. Then I added the throws crop exception to the first line of the method. Here, when we throw a crop exception instead of returning a -1, it includes a message explaining what is wrong. If the acres to buy are less than 0, it throws a message explaining that they must enter a positive number. If the wheat in store is less than the acres to buy multiplied by the land price, it will throw a message explaining that there is insufficient wheat to buy that much land. Another thing to notice with exceptions is that nothing is returned at the end of the method. Next, I'll show you the byland method in a try block. I did this because we know that byland could throw an exception. Then I add a catch block to handle the exception if it is thrown. Everything within the try block either calls a method that could throw an exception or is any code that I want to skip when an exception does occur. Everything within the catch block is the code that I want executed when an exception is caught. If an exception is caught, we want to stay within the loop. That way the user can enter a different value for the number of acres to be bought. That is why the beginning of the loop has a params not okay set to false. And if we end in the catch block, it is set to true. So if params not okay is true, we will stay within the loop so they can enter a different value. Okay, so here we have character versus byte stream. Okay, so we have byte stream, it processes data byte by byte with it being 8 bits. File input stream is used to read from the source, and file output stream is to write to the destination. System in and system out are the byte streams that we have been using in our City of Erin game. With a character stream, there's non-Unicode bits, input stream, Unicode character stream, output stream, and non-Unicode bytes. So, in other words, in Java, characters are stored using Unicode conventions. Character stream is useful when we want to process text files. This text file can be processed character by character. A character size is typically 16 bits. Byte-oriented reads byte by byte. A byte stream is suitable for processing raw data like binary files. In the next few slides, you will see an example of writing a character data to a file. The start save game method's purpose is to get the file name from the user, and then pass this file name to the method in the game control class. Then we'll load a save game from the disk. Then the start save game method starts the game. The display save game view follows the same rules. Its purpose is to get the user to name the game something and save it. After a game is saved, it can be retrieved, or it will go through the file path loop created in getSaveGame and the SaveGame methods. Here we have the try block for the getSaveGame method and the SaveGame method, and the catch block for both of those methods. The purpose for these methods are to save a game from a disk and load a game from a disk. When loading a save game from a disk, the file path is inputted. When saving a game from a disk, the file path is outputted. Now I will demonstrate my game a little bit. So here we will go to my Java beans, and I will start a new game. And I'll put in my first name. It welcomes me, and then I want to view my map. Okay, so here we have my village map and my key. So you can see the desert, the granary and the storehouse, and the ruler's court, the undeveloped land, the village, the wheat field, and here's my river, and the border of the Lamanites' land. Okay, so we viewed the map. Now let's view a list. Okay, so here's our list menu, and we can go and see the animals. Okay, so we have my animals here printed out, the horse, cow, chicken, and pig, and their quantity there. So let's return back, and now let's manage the crops. Okay, so how many acres land do I wish to buy? Let's say -1. Okay, so it says it throws an exception. I can't do this. Please enter a positive number. Okay, so let's do 2. Okay, so that worked. What percentage do I want to pay? Let's do 4. And how much do we want to plant? Let's do 2. Okay, so there we go with that. And now let's go back here and let's save my game. Save it as Adri. Okay, so now it's saved. And now let's return. And now let's get my start game. Saved game. So choose a save game. Let's do 10. Okay, so there was an error because we don't have that save game. So let's